now discuss evaluating some very basic algebraic type of expressions, along with discussing the order of operations and how to properly use it. So we'll start with exponents. First, what exactly is an exponent? A number like a to the n means we're going to multiply a by itself n times. The number a is known as the base, and the number n is known as the exponent. A few examples. 3 to the 4th would mean 3 times 3 times 3 times 3, which is 81. Something like -7 squared would be -7 times -7, which is positive 49. If on the other hand I have -4 squared without parentheses, this actually means -4 times 4, which would be -16. So parentheses with exponents are very, very important. If you have them, then you're actually raising the negative number to that power. And if you don't, you're actually raising the number to that power and then inserting a negative. One last example, -2 to the 5th. This would be -2 times -2 times -2 times -2 times -2, which would be -32, since there are a total of 5 negative signs. The next type of expression we'll look at evaluating are roots. If we see an expression like this, the nth root of a equal to b means b to the n is equal to a. So if I'm looking for something like a cube root, it means what number can I cube to get this? Maybe we want to do the 4th root or the 5th root. However, if n is actually equal to 2, we just denote it as the square root of a equal to b, and not actually write the index of n. But that only happens if our value of n is 2. So let's do a few examples. The square root of 36 would be 6, since 6 squared is equal to 36. The cube root of -27 would be -3, since -3 cubed is -27. The square root of 25 over 9 is 5 over 3, because 5 over 3 squared is 25 over 9. If I try to do something like the square root of -16, this number actually does not exist. So D&E stands for does not exist, because 4 squared would be +16, and -4 squared would be +16. There's no number that when I multiply it by itself, I get a negative number. So if we take a square root of a negative number, it doesn't exist. However, as we saw in the second example, a cube root could exist. We'll now look at order of operations. In the United States, this is usually called Pemdas, parentheses, exponents, multiplication, division, addition, subtraction. But that can actually be very deceiving in particular types of problems. So we're going to rearrange it slightly. The first step is groupings. These are including parentheses, brackets, braces. A very big division sign can indicate a grouping. Essentially, any types of those parentheses or any types of grouping symbols we want to evaluate first. The second step would be to do exponents and roots. As we'll see in a later video, square roots and cube roots, and in general higher roots, are the same thing as exponents. That'll be expanded on more fully in a later video, but for now, we'll just assume that they are exponents and should be evaluated second. The third step is to multiply and divide left to right. So evaluate any multiplications and divisions as we're moving left to right. One of the biggest mistakes in memorizing Pemdas is assuming that multiplication comes before addition, but they should actually be evaluated at the exact same time. The very last step is addition and subtraction. Once again, we're going to move left to right and actually just add and subtract anything that's left. And that's our final step. So we'll do a few examples to demonstrate this. Here is a quite complicated example of something we would want to use order of operations for. We need to start with grouping symbols, and we have a lot of grouping symbols here. So we start with the innermost grouping symbol, which is this one here. This is considered the most inner because there's no other grouping symbols inside of it the way there are with the rest of them. So we now have 12 plus 6 divided by 3 times 2 minus 2 times 2 squared minus 8. And now we are back to grouping symbols. We still have other grouping symbols. In particular, we have a new internal grouping symbol. This one has more than one operation going on inside of it, so we need to follow our order of operations. First is grouping, but there's no grouping symbols inside of this, so the next step would be exponents. So we have 12 plus 6 divided by 3 times 2 minus 2 times 4 minus 8. Next, we multiply and divide inside of that grouping symbol. So this time, 4 times 2 is 8 minus 8. And now we can finally do the last part of that grouping symbol, which is subtract. And we get 0. So minus 0. The next step would be to do our next grouping operation, which is our final one. We need to multiply and divide left to right. So we start by doing 6 divided by 3 to get 2. 2 times 2 is then 4. And 12 plus 4 is 16. Like I said, people usually get tripped up whenever they want to multiply and divide and want to multiply first. If we would have multiplied first, that bracket here would have turned into a 1 rather than a 4, and that would have been incorrect. Here we have one that has this big division symbol in it, which actually works as a grouping symbol. So we need to evaluate the top and the bottom separately and then divide at the end. If we start with the top, the first thing we need to do is add up those things inside of that square root. 9 plus 16 is 25. Inside of that square root would be considered a grouping symbol. The grouping symbol in the denominator would be that absolute value. And the first thing we do is multiply. 2 times 6 is 12 minus 18. The next step, we still have stuff going on inside of grouping symbols. 9 minus 12 would be negative 3, and the absolute value of negative 3 is positive 3. We can now evaluate exponents and roots. The square root of 25 is 5. We don't have any multiplications on the top or divisions on the top, same thing on the denominator. So now we can add. 8 plus 5 is 13. 3 minus 18 is negative 15. So my final answer, negative 13 over 15.